Have you ever dreamed of touching the sun? It sounds like something straight out of mythology, right? A feat reserved for gods and legends. Well, humanity has just done it. NASA's Parker Solar Probe has officially touched the sun, venturing where no spacecraft has gone before, right into our star's scorching atmosphere, the corona. This isn't science fiction. It's a monumental moment in our quest to understand the universe. For years, we've studied the sun from a safe distance, but now we're finally getting up close and personal. Imagine a spacecraft traveling at hundreds of thousands of miles per hour, braving temperatures hot enough to vaporize most metals, all to answer some of the biggest questions we have about our star. The Parker Solar Probe is an engineering marvel equipped with a revolutionary heat shield that protects its sensitive instruments from the sun's relentless fury. And on April 28, 2021, after a journey of over 3 years, it crossed a critical boundary known as the Alphen critical surface. This is the point where the sun's atmosphere officially begins. For the first time, a human-made object was flying through the sun's corona, directly sampling the particles and magnetic fields within it. Think about what this means. It's like studying a hurricane, but instead of just watching from afar, you're flying a drone right into the eye of the storm. For decades, everything we knew about the solar wind, that stream of charged particles flowing from the sun, was based on measurements taken millions of miles away. It's like trying to understand a waterfall by looking at the river downstream. You get some information, but you miss all the chaotic, powerful action happening at the source. The Parker probe is now at that source, and it's finding some incredibly bizarre things, the most mind-boggling discoveries so far. Something scientists are calling magnetic switchbacks. Picture the solar wind as a superhighway of particles and magnetic fields streaming out from the sun. We expected it to be a relatively straight shot. But that's not what Parker found. Instead, it detected these strange, S-shaped kinks in the magnetic field. For a few seconds or even minutes, the magnetic field would suddenly flip its direction completely, almost 180 degrees, before snapping back to its original orientation. This is a huge puzzle. It's like driving down a perfectly straight road and suddenly finding yourself momentarily driving in the opposite direction before being corrected. It's a phenomenon that completely defies our previous understanding of how the solar wind behaves. These switchbacks are not just minor wiggles. They are powerful, energetic events happening all over the place inside the sun's atmosphere. We had seen hints of them in data from other spacecraft, but they were rare and far from the sun. Now, Parker is finding them to be common, a fundamental feature of the solar corona itself. So, the billion-dollar question is, what's causing them? Right now, scientists are baffled. There are a few leading theories, but no one knows for sure. One idea is that they are the result of a process called magnetic reconnection. Imagine magnetic field lines near the sun's surface getting tangled up. When they snap and reconnect, they could launch a wave or a jet of particles that propagates outward, creating these zigzag patterns in the solar wind. It's like snapping a whip. The energy travels down the line in a wave. Another theory suggests they are born from the convective motions on the sun's surface, the very granules that make the sun look like it's boiling. Think of them as giant bubbles of hot plasma rising and falling. The movement of these massive cells, each the size of a large country on Earth, could be twisting the magnetic field lines rooted within them. As the solar wind flows past, it might carry these twisted, S-shaped structures outward into space. It's a bit like how a spinning propeller creates turbulence in the air behind it. Understanding these switchbacks is crucial because they could be the key to solving two of the longest-standing mysteries in solar physics. First, the coronal heating problem. The sun's surface is about 10,000 degrees Fahrenheit, but its atmosphere, the corona, is millions of degrees hotter. How is the corona getting superheated? It completely defies the laws of thermodynamics. It's like walking away from a bonfire and getting hotter instead of colder. These switchbacks are packed with energy. Could the dissipation of these magnetic structures be the mechanism that's dumping heat into the corona, raising its temperature to unimaginable levels? The second mystery is the acceleration of the solar wind itself. What pushes this stream of particles to speeds of over 1,000,000 miles per hour? The switchbacks are associated with bursts of speed in the solar wind. They seem to be giving the particles an extra kick as they pass by. So, are these switchbacks acting like a series of accelerators, slingshotting solar particles out into the solar system? If so, understanding them would fundamentally rewrite our models of how stars interact with their environments. This is more than just an academic puzzle. The solar wind and the magnetic storms it carries can have a direct impact on us here on Earth. This phenomenon, known as space weather, can disrupt our GPS systems, damage satellites, and even knock out power grids. A more accurate understanding of the solar wind's origin and acceleration means better space weather forecasting. By understanding what happens at the sun, we can better protect our technology-dependent society from its powerful outbursts. The journey of the Parker Solar Probe is far from over. With each orbit, it gets closer and closer to the sun, plunging deeper into the corona and gathering more data. It will continue to fly through these switchbacks, measuring their properties in unprecedented detail. Are they hollow tubes or filled with particles? How fast are they moving? How much energy do they carry? Each piece of data is a clue that brings us closer to solving this incredible cosmic mystery. What the Parker probe is doing is exploration in its purest form. It's pushing the boundaries of what's possible, venturing into an alien environment to answer fundamental questions about our place in the universe. We are living in a golden age of space discovery, where a machine built by human hands is flying through the atmosphere of a star, unveiling secrets that have been hidden for billions of years. The story of the sun is our story, and we are finally beginning to read its most exciting chapters. Thank you so much for joining me on this incredible journey to the sun. It's discoveries like these that remind us how much we still have to learn about the cosmos. If you found this as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the wonders of our universe. Let me know in the comments what you think is creating these mysterious switchbacks. Until next time, keep looking up.